Welcome back to mahasarkar.co.in. In today's video, we are going to start with new article composition of SHMs. What is composition? According to principle of superposition of waves, if two waves overlap, the resultant displacement is vector sum of the individual displacement of the two or more than two waves. So we are going to use this principle to find out the composition of two simple harmonic motion. What is the result of that composition also that we are going to study. So suppose we have two simple harmonic motions of slightly different amplitude and different phases. So say the first equation of SHM is x1 equal to a1 sine omega t plus alpha 1, and second equation of motion is x2 equal to a2 sine omega t plus alpha 2, where a1 is the amplitude of first wave and alpha 1 is the phase of the first wave, a2 is the amplitude of second wave and alpha 2 is the phase of the second wave. Okay, now by composition formula I can write the resultant displacement is equals to x1 plus x2. So substituting here I will write a1 sine omega t plus alpha 1 plus a2 sine omega t plus alpha 2. Okay, now just all the mathematics. Simplify. This is sine a plus b. What is the expansion for sine a plus sine a plus b? I will call this is a and this is b. Similarly here also a and b. Then see a1 constant sine omega t sine a cos b plus a1 or directly sine cos omega t sine alpha 1. Okay, sine a plus b, sine a cos b plus cos a sine b. I am also getting fumbled, students, so write carefully. This also we are going to simplify by the same way, a2 into sine of omega t cos alpha 2 plus cos of omega t sine alpha 2. If I take a1 and a2 in bracket, then as you can see here, a1 sine omega t and a2 sine omega t. So sine omega t will be common, here cos omega t will be common. So I will write that terms separately like a1 cos alpha 1 plus a2 cos alpha 2, and what is common from this? See, sine omega t plus, see, it is very simple step. I have multiplied this entire bracket with a1, and if I add them, then these two will be added, so sine omega t is common. Okay, similarly here, what is common? Cos omega t will be common. So how will you write? a1 sine omega alpha 1 plus a2 sine alpha 2 into cos omega t. Now as you can see, the term in the bracket consisting of the constant means the values of amplitude and phase. So if a1 represent amplitude, alpha 1 represent phase, here also, here also. So I am going to substitute this bracket as another term. So put a1 cos alpha 1 plus a2 cos alpha 2 is equals to r into cos delta. Now here what is represented? R is representing, then r will be representing addition of a1 and a2. So r will be considered as what? Resultant amplitude. We don't know exact magnitude, but we can say r will be combination of what? a1 and a2. Whereas delta will be combination of what? This alpha 1 and alpha 2. Similarly, for this bracket, a1 sine alpha 1 plus a2 sine alpha 2 equal to r cos delta. So if I substitute these values, then what I am going to get? X equal to, then x equal to, see, this bracket is now what? This bracket is what? R cos delta, and the lower bracket is what? R sin delta. So it is like r cos delta into this sine omega t plus r sin delta into cos omega t. What is common? R is common. So what we will get in bracket? sin omega t into cos delta plus cos omega t into sin delta. See, omega t is a and delta is b, so it is like sin a cos b plus cos a sin b. So it is expansion of sin of a plus b, so r into sin of omega t plus delta. So what I can conclude from this, that composition of two simple harmonic progressive waves of different amplitude and different phases is also what? Simple harmonic progressive wave with same frequency, that is omega, same angular frequency, but where, so this equation say 3, equation 3 represents that the composition of SHMs is also SHM with R as resultant amplitude, with R as what? Resultant amplitude, and delta as what? Resultant phase. Okay. R is what? Resultant amplitude, and delta is what? Resultant phase. Now we can have these two equations to find value of R also. So let's find this value. See, this is equation number 3 and this is equation number 4. So what I can do is to find value of R, what I am doing is squaring and adding equation 3 and 4. So what we will get? To find resultant amplitude, we are going to find out what? Now resultant amplitude, that is equation for R. So squaring and adding equation 3 and equation 4. Square this and add. So RHS लिखो, LHS लिखो, ही लिखो आदि. So squaring R square cos square delta plus याचा square R square sin square delta equal to A1 cos alpha 1 plus A2 cos alpha 2 whole square plus A1 sin alpha 1 plus A2 sin alpha 2 whole square. I hope you are able to see the lower part. Yes, it is visible properly. Okay. Now simplify the steps. What we will get? Just make the square of the bracket. See, R square is common, so R square common. What we will get in bracket? Cos square delta plus sin square delta is equals to squaring A square plus B square plus 2AB. So A square of this one काय मिळणार? A1 चा square cos square alpha 1 plus B चा square म्हणजे कसला square? A2 चा square cos square alpha 2 plus 2 time AB ना 2. A किती आहे? This one and this one. So it is like A1 A2 cos alpha 1 into cos alpha 2 plus जसं cos आहे तिथे the same sin. So A1 square sin square alpha 1 plus A2 square sin square alpha 2 plus 2A1 A2 sin alpha 1 into sin alpha 2 plus बघा cos square theta plus sin square theta is always 1, so it will be r square only equal to. आता see, I am adding the terms. If I add this both term, what is common? A1 square. What is remaining there? Cos square alpha 1 plus sin square alpha 1 plus same here. A2 square. What is remaining here? Cos square alpha 2 plus sin square alpha 2 plus adding this 2. What is common? 2A1 A2. So 2A1 A2 is common, and in bracket what we are getting? Cos alpha 1 alpha cos alpha 2 plus sin alpha 1 sin alpha 2. Done. ही कसली व्हॅल्यू आहे? sin square theta plus cos square theta 1. हा सुद्धा 1 आणि याला a म्हणा. This is a, this is b. So it is like cos a cos b plus sin a sin b. कसलं एक्सपान्शन आहे? cos of A minus B. So what we are going to get? R square is equals to A1 square plus A2 square plus 2A1 A2 into cos alpha 1 minus alpha 2. Yeah. So what is R equal to? Therefore R is equals to root of A1 square plus A2 square plus 2A1 A2 into cos alpha 1 minus alpha 2. This is the derivation for resultant amplitude of particle performing composition of SHM. Okay, combination of SHM. झालं. इथं तुम्ही काही कंडिशन लिहू शकता. स्पेशल केसेस. If alpha 1 minus alpha 2 equal to 0, therefore cos 0 equal to 1. तर मग काय होईल? R equal to root of बघा हा 1 होईल. So it is like A1 square plus A2 square plus 2A1 A2. कसलं एक्सपान्शन आहे हे? रूट मध्ये A1 plus A2 bracket square. So it will be like what? Simply A1 plus A2. If there is no difference in the phase, then we can get directly addition of two waves. If say alpha 1 minus alpha 2 are equal to 180 degree, म्हणजे दोन्ही एक इकडे आणि दुसरं तिकडे जाते. 180 डिग्रीचा फेज. cos 180 डिग्री minus 1 असल्यामुळे हा मायनस होईल, हा मायनस होईल, हा मायनस होईल. Therefore directly I am writing A1 minus A2. Third case, if alpha 1 minus alpha 2 equal to 90 degree, then cos 90 degree काय असतो? 0 असतो. So if this will be 0, then R equal to what we will get? Only R equal to root of A1 square plus A2 square. These special cases you will require to solve some MCQs in the CET exam. Okay. Now finally we will find the resultant phase. We will just require the formula resultant phase indicated by del. Dividing equation, इथं काहीतरी चुकलं माझ्या लिहिताना, सॉरी. इथं हा साइन द्यायचा पाहिजे. ओके, मी इथं बरोबर लिहिलंय सगळ्या ठिकाणी, इथं रॉंग झालं होतं. इग्नोर द मिस्टेक. ओके, नाउ डिवाइडिंग इक्वेशन 4 बाय इक्वेशन 3 काय मिळेल बघा? LHS ला R sin डेल्टा डिवाइडेड बाय R cos डेल्टा इक्वल टू काय मिळणार आहे? A1 sin alpha 1 plus A2 sin alpha 2 divided by A1 cos alpha 1 plus A2 cos alpha 2. R cancel, sin delta upon cos delta will be what? Tan delta. Tan delta is equals to the same term A1 sin alpha 1 plus A2 sin alpha 2 divided by A1 cos alpha 1 plus A2 cos alpha 2. Therefore delta equal to tan inverse of the same term that you can get. This is the composition of two simple harmonic progressive waves. I hope you understood this article also. Thanks for watching mahasarkar.co.in. Have a nice day.